So hi guys, my name is Jerez Kirk Villapaz and I'm here in front of you to report about the geophysical investigations in civil engineering. But first, let's talk about geophysics. What is geophysics? Geophysics is the mathematical and scientific study of the Earth's mechanics and structure. This encompasses anything from understanding the microscopic characteristics of minerals and rocks to global processes like earthquakes and climate change. Next is geophysical investigation. Geophysical investigations measure, analyze, and interpret seismic, electrical, electromagnetic, gravitational, and magnetic fields recorded at the ground surface or within boreholes to determine the physical characteristic of the surface or of the subsurface. The majority of boreholes investigation, with a few exceptions, provide detailed information about subsurface materials only in the immediate vicinity of the borehole of between boreholes. So I will show you a video that will explain further what is the geophysical investigation. So here it is.
Geophysical surveys cover a range of techniques that allow geologists literally to image or see different rock types and rock structures down to several kilometers beneath the Earth's surface. As the name suggests, geophysical surveying is able to measure the physical properties of the rock, for example, density, hardness, electrical and magnetic properties, and the different kind of fluids that are contained within the cracks and pore spaces. This type of surveying was most highly developed by the oil and gas industry, and one type of surveying technique in particular has been very effective at discovering huge quantities of oil and gas. It relies on producing sound waves and timing their passage through rocks. It's known as seismic surveying, and it works in a similar way to the technique that produced these ultrasound scans of babies in the womb. Sound pulses travel through the mother, reflect off the unborn child, and produce the image. Seismic works in exactly the same way, but on a much larger scale. Seismic surveying involves sending sound waves through the ground and measuring the time it takes for them to reflect off different rock boundaries and back up to the surface. Computers are used to analyze these timings and translate them into a cross-section image of the rocks below the survey area. Seismic surveys will be a key technology in RWM's site characterization program. In combination with other geophysical investigations, seismic surveys will allow RWM geologists to map the shape of rocks below the surface between boreholes, to predict the certain characteristics of different rock types, and to identify the presence of faults and fractures deep underground with dimensions of no more than a few meters. Using these techniques and others, RWM geologists will build a detailed three-dimensional picture of the underground environment in which we plan to build a geological disposal facility.
So yeah, that's the geophysical investigation. So let's talk about site investigations. What is site investigation? This is a process of gathering information, analyzing the data, and identifying undiscovered dangers beneath a site. So there are different methods on investigating the geophysical area. First is the seismic method, which is discussed earlier in the video. So I will explain it further. So for engineering studies, seismic techniques are the most widely used geophysical surveys. Engineers and geologists get the most basic geology data from seismic refraction using simple techniques and standard equipment. So the tools or the medium that's used in the seismic service are first is the special designed vehicle known as the vibrosis or vibrosis truck. So this truck drops a plate on the surface to conduct seismic testing. The plate produces an acoustic sound signal which is carried through the Earth's surface and reflected by various geological strata. Next is the small microphones, which are called the geophones. It is placed together along with the predefined and prepared course called seismic line seismic line record the returning sound waves. So the data from the geophones is sent through thin waves or thin wires to a recording vehicle that is normally parked on the roadside. So that is the medium is used in recording the seismic waves. So the next method is called the gravitational method. In engineering, environmental, and geothermal studies, it's been utilized to identify the voids, faults, subsurface, stream valleys, water tables, and geothermal heat sources. So the tool that is used in recording the gravity field in gravity fields is what we call the gravitometer or the gravimeter. This is a device that monitors the Earth's gravitational field at specific locations. This gadget works by measuring the constant downward acceleration of gravity. They work by measuring the acceleration of a mass in free fall in a vacuum. So next is the electromagnetic method. The uses of electromagnetic service or investigation, both airborne and on the ground, is one of the most frequent approaches in mineral prospecting. The approach excels in detecting conductive sulfide deposits with substantial conductivity differences between ore bodies and country, or host rocks, or thin overburden cover using direct detection. The medium that is used in the electromagnetic investigation is what we call the GPR or the ground penetrating radar. It is the GPR is a geophysical locating technique that employs radio waves to collect pictures under the ground surface in a non-invasive manner. The ability to locate the position of subsurface services without disturbing the Earth is a significant benefit of it, the GPR. So next method is the radioactivity method. The radiometric or the gamma ray spectrometric technique is a geophysical method for estimating potassium, uranium, and thorium contents in the near surface. This is accomplished by detecting the gamma ray emitted by these elements' radioactive isotopes during radioactive decay. By detecting gamma radiation above the ground from low-flying airplanes or helicopters, airborne gamma ray spectrometric service estimate radio element concentration at the Earth's surface. So the medium that's used is what we call the gamma ray logging. This is a technique for characterizing the rock or sediments in a borehole or drill hole by detecting natural occurring gamma radiation. It is a type of wireline logging used in mining, mineral exploration, water well drilling, formation assessment, and oil and gas well drilling, and other applications. Next method is the magnetic method. A magnetic survey or investigation is used to look into subsurface geology using anomalies in the Earth's magnetic field caused by the magnetic characteristic of the underlying rocks. Magnetic content or the susceptibility of rocks varies greatly depending on the kind of rock and the environment in which it found. So the magnetometers can detect the magnetic field changes produced by deposits. They are employed in geophysical service to identify iron deposits, shipwrecks, and other buried or submerged items are also detected using the item or the magnetometers. So next method is the electric method, or this is the last method. So surface effects is caused by electric current flow in the ground are detected using electrical geophysical prospecting methods. Potential currents and electromagnetic fields that occur naturally are intentionally introduced on the ground can be measured using electrical technique. So electric methods is the same with electromagnetics, but it focuses on using electricity, not magnet. So the most commonly used near-surface geophysical technique, particularly for environmental research, are electrical methods. Electrical methods utilizing active sources, resistivity, and induced polarization offers a variety of field inquiry methodologies, including surface-based imaging and borehole-based imaging. So the electric methods uses electrical resistivity. The apparent resistivity of soils and rocks is measured as a function of depth or location using the electrical resistivity. It is computed by calculating the geometric factor unique to the array and electrode spacing by the observed potential difference divided by the input current. So those are the methods that is used in different types of geophysical investigation or surveys. So I think that's it. So again, my name is Jaros Kirk Villapaz, and that's my report about geophysical investigations. Peace.